In this video, you're going to learn how to develop a Spring Boot application using microservices architecture. This is going to be a highly practical tutorial, so to follow along, I expect you to have at least a basic understanding about Spring Boot and basic understanding of what microservices architecture is and why we use them. So we'll be building a simple online shop application using microservices architectural patterns, using mainly Spring Boot and the latest Spring Cloud technologies. So we're going to cover all the interesting and important architectural patterns like service discovery, centralized configuration, distributed tracing, event-driven architecture, centralized logging, and much more. If you're not aware of what are these fancy terms, don't worry, we'll cover this in the tutorial. So before going ahead and implementing our microservices, let's take a moment to understand what is Spring Cloud. Spring Cloud is a project under the Spring Projects ecosystem. So it's another project like Spring Boot, Spring Data, Spring Security, or any other Spring project, but it mainly concentrates on helping us to build the reliable and robust microservices. It provides us a common set of design patterns which are implemented already, like the configuration management, service discovery, circuit breakers. And there are many other patterns which are implemented into the Spring Cloud project. We'll have a look at it in depth in this tutorial. You don't need to worry about that. We are going to use Spring Cloud to mainly develop the microservices. That's what you need to know. As you understood what is Spring Cloud, now let's go ahead and check what are the different services we're going to build in this tutorial. So the first service we're going to build is going to be a product service. So this service provides us an API to create and view products in our application, and it also acts like a product catalog where we can view all the products inside our application. So the next service is going to be an order service where we can order the products which are available in the app, and after that we are also going to have an inventory service where the order service can check if the product is in stock or not before submitting the order. And lastly, we're also going to have a notification service where we can send email notifications after the order is placed successfully. And out of these four services, we are going to mainly have the order service, inventory service, and the notification service talk to each other. We mainly have the asynchronous and as well as synchronous communication as part of these three services. So now let's go ahead and check the overall solution architecture of our project. Alright, so this is how the solution architecture diagram looks like. So mainly we are going to first look at the services we are developing. So we have the product service, which is talking to MongoDB, and an order service, which is talking to the MySQL database, and the inventory service is also talking to the MySQL database to store all the inventory information. And we have the notification service, which is like a stateless service, which it does not have any database, but it is responsible to just send out notifications to the users. If you're talking about a microservice architecture, you cannot call it as a microservice architecture if the services are not talking with each other, right? So here the order service is talking to the inventory service. So whenever an order is being placed, we'll first check whether the inventory is available or not by making a synchronous communication. And after that, we are also going to send out the notification once the order is being placed successfully. So for that, we are going to make an asynchronous communication with the notification service. If you're not sure what is synchronous and asynchronous communication, don't worry, we will also cover this in detail in this tutorial. Coming to the asynchronous communication, we are going to make use of two softwares, like we will call it as message queues. So we are going to see how to deal with both the popular message queues in the market, like the RabbitMQ as well as Kafka. So we will see how to configure both of these message queues to do the asynchronous communication. And coming to the outside world, we have the surrounding services which enable the microservice architecture. We have the API gateway, which acts like a gateway to send the requests from the user to different services. So for example, if I am a user and I want to communicate with the product service, I don't want to give the host name or the IP address of the product service to communicate with it, right? So the API gateway acts as like a gatekeeper to send out the requests to different services we like. So our applications is also being secured using the authorization server called as Keycloak. We'll also have a look at it in the detail. And other than that, we also have different services like Eureka, the config server. We're also going to use Vault to store the secrets. we're going to use Zipkin to do the distributed tracing, and also to do the logging, to do the centralized logging. We're also going to use Elasticsearch, Logstash, and Kibana. And again, don't be overwhelmed with all these details. We will have a look at each of them in detail in this tutorial. Alright, so if you'll have a look at the logical architecture of each of the services, we have a controller, service, and a repository layer for each of the services. So in the controller layer, we will be receiving the HTTP request from the clients, and from there the business logic is being executed on the service layer. And in some of the services, we are also going to communicate with a message queue. So that's why we have this message queue communication, and mainly in the order service we are going to make use of the message queue and also the notification service. And after that, we are also going to store the information in the database. So for that, we are also going to maintain a repository layer which mainly talks to the database. So we have a Postgres and also the MongoDB database. So both of them will follow the same pattern. We'll have a repository which talks to the database. This is how almost all the services are being structured. So we'll follow the same process for all the services we have. Alright, so let's start coding. So first we are going to develop the product service. For that, I'm opening the website start.spring.io where you can generate the initial version of the code. So for that, I'm going to select this latest Spring Boot version as of creating this tutorial, that is 2.6.4. And for the group ID, I'm going to provide the text com programming techie, and the artifact is going to be product service, and the description is going to be also product service. You can enter whatever description you like. I'm going to use Java 17, and for the dependencies, I'm going to first make use of Lombok to reduce the boilerplate code, and I also need access to Spring Web, so that we are going to make use, as we are building a REST API, so I'm going to use Spring Web. And lastly, I'm also going to add Spring Data MongoDB, as the product service is going to communicate with a MongoDB database. After adding all these dependencies, I'm going to click on generate, and the product service is going to be downloaded to your machine. So I'm going to first unzip and open it on my favorite IDE. The first thing we have to do is to configure the MongoDB URI inside the application.properties file. I'm going to give the database name as product service. If you want a detailed explanation on how to configure Spring Boot with MongoDB, have a look at the Spring Boot MongoDB playlist in my channel. You can also find this in the description section. After that, we have to create our domain model, which is the product class. So let's create a package called as model, and inside the package, I am going to create a class called as product. To define this product as a MongoDB document, I'm going to add the document annotation to the top of the product class. And I'm also going to add the Lombok annotations to generate the getter-setter methods and the constructors. Inside the class, I'm going to create the required fields, which are ID, name, description, and price. And to the field ID, I'm going to add the ID annotation from Spring Data to specify that this is a unique identifier for our product. And to store this product inside the database, we have to create a Spring Data repository. For that, I'm going to create a package called as repository, and inside this package, I'm going to create an interface called as product repository. And I'm going to extend this interface with the Spring Data MongoDB's Mongo repository interface. And I'm going to pass in the generic argument as product. And for the identifier, I'm going to pass a string as the second generic argument, because this is the type of the ID field in our product class. Now it's time to create the controller class. So for that, I'm going to create a package called as controller, and inside the package, I'm going to create a class called as product controller. As we are exposing a REST API, we have to add the REST controller annotation to the top of this class, and also the request mapping annotation with value /API/product. So now let's create the API to create the products. So for that, I'm going to create a method called as public void create product. And this method, as this creates some products, we are going to send a post request for this method. So I'm going to add the post mapping annotation, and as a response we are going to type in response status, and we are going to send out the HTTP status as created. So I'm going to select HTTP status created, right? And as a request body, we are going to receive the product information. For that, we are going to create a new class called as product request, right? So this is going to act as a DTO. So I'm going to create this class inside a new package called as DTO, and also this class is going to have a Lombok annotation to create the getters and setters called as data. I'm going to use the builder annotation to create the builder method, and also the allocs constructor and the noaux constructor. So inside the product request, we're going to mainly have 3 fields similar to what we have in product. So I'm just going to copy paste these 3 fields inside the product request. Alright, so we'll have name, description, and as well as the price. So now we have the product request, and let's go back to the product controller, and we are receiving the product request as the request body. And to actually create the product, we have to do the processing, like the processing of the business logic in the service layer. You can't do it on the controller layer. So for that, I'm going to create a new package called as service. And in here, I'm going to create a new class called as product service. So as this is a service, we are going to add a Spring Boot annotation called service, and we are also going to create a new method inside here called as public void create product, which takes in the product request as the method parameter. And inside here, we have to first map the product request to the product model. So for that, I'm going to create a variable of type product. So let's also import the product from the package, from the model package, and create a reference variable called product. And I'm going to make use of product.builder method, so to build the product object. So for that, I'm going to type in the name as product request.getName, and the description as product request.getDescription. Lastly, the price as product request.getPrice. And once we have set up all these information, I'm going to call the build method so that it will create the object of type product with all the requested details. And lastly, we have created the instance of the product object. Now we have to save this into the database. So for that, we need to access the product repository. So I'm going to inject the product repository into a service class, the product service class. Mainly, I'm going to make use of constructor injection. So I'm going to type in private final product repository. And after I have added the declaration of product repository, you can see that IntelliJ is already complaining that the product repository is not initialized. So I'm going to add the constructor parameter here. So you can see the constructor is automatically generated. So instead of doing this manually for all the classes, what I can do is I can just remove this constructor which is generated, and I can add the annotation required args constructor from Lombok. So what this will do is at the compile time, it will create the constructor for us, which all the required constructor arguments, right? So this is something handy which we can use. So now I'm going to save this product inside the database by typing product repository dot save product. So after doing that, the product will be saved successfully to the database. We can also add some logs here by making use of SLF4j. So I'm going to type in SLF4j. So this is coming from Lombok, and to add the logs, I'm just going to create a new line under the save method. I'm just going to type in log.info product is saved, right? So we also have to give the information which product is saved, right? So maybe a product ID would be useful. So for that, instead of concatenating the product ID like this, like product.getID, something like this, Using SLF4j, we can actually make use of a placeholder. So I'm just going to add a placeholder like a double curly brace, and after that I'm just going to type in comma and add product dot get ID. So what this will do is it will dynamically it will get the ID of the product and it will replace it on the placeholder. So when you execute this, you will get product followed by the product ID is saved, right? So we have the create product method. So now let's also let's call this create product method from the product controller. So as we did similarly for the product service, we also have to inject the product service inside the product controller. So for that, I'm going to type in again private final product service, and to inject product service, I'm going to make use of again the required args constructor from Lombok. So now we have the product service. I'm just going to call inside the create product method product service dot create product, and I'm going to pass in the product request. So this will create the endpoint to create the products. So now I'm going to create another endpoint to retrieve all the products. So for that, I'm going to create another DTO called as product response. And similar to what we did for the product request, so I'm just going to copy everything we have inside all the annotations we have defined for product request called product response. And inside the product response, we are also going to send the ID in addition to the name, description, and price. So for that, I'm just going to copy everything we have inside the product model class. So I'm just going to type in product response. So now you may be confused why I have created a separate class called as product response, right? So maybe why can't we directly use the product class from the model package instead of creating the product response? This is because it's a good practice to separate your model entities and the DTOs. So ideally you should not expose your model entities to the outside world, because if in the future in this product class, if I've added some other two fields which are like necessary for the business model, we should not expose these two fields which are not necessary outside to the outside world, right? So for this reason, it's a good practice to separate your model entities and also your data transfer objects. So in this case, the product request and the product response acts as the data transfer objects. So now I've created the product response. So to create the get endpoint, so get all products endpoint, I'm going to first type in a get mapping annotation, and this response status annotation is going to send a response status of HTTP status OK, right? And now I'm going to type in public list of product response, and I'm going to call it as get all products, and I'm going to import this list class from java.util package. And now I'm going to create a method inside product service to get all the products. So I'm going to call in product service dot get all products. So I'm going to create this method as this is not existing yet inside the product service. So this get all products should return a list of product response. So I'm also going to import this list from java.util package again quickly. And in here, I'm going to type in product repository dot find all, because I want to first read all the products inside the database. So I'm going to store it inside a variable called as products. And now I have to map this product class into a product response class, right? So for that, I'm going to type in products dot stream dot map. I'm going to make use of Java 8 streams and the map function, and I'm going to map each product into a product response object. So for that, I'm going to create a new method called as map to product response. I'm going to create a new method inside the product service. So this is should not return an object, but should return a product response, right? So here I'm going to create a object for product response using the builder method. So I'm going to select response.builder.build, and as part of the builder, I'm going to provide the ID as, you know what, we don't have the product as an input argument, so let me add the product as the input argument here to the map to product response method. So now we have the product, so I can just map the ID of the product to the ID of the product response by typing in product.getID, and again name as product.getName. So let me just scroll down to make it visible clearly. So again we have the description, so I'm going to type in product.getDescription, followed by the price. So I'm going to type in product.getPrice. So now we are creating the object of product response and returning it back to the getAllProducts method. And in here, IntelliJ is suggesting some changes here. So as we are using a method inside the class, we can actually make use of the method reference instead of lambda. So I'm just going to select replace lambda with method reference. And now after we mapped it, we are going to collect it into a list. So I'm going to call toList method, and finally I'm going to return this list back to the controller. So we have the getAllProducts, which is returning a list of product responses, if a list of product response objects. So now I'm going back to the product controller, and I'm going to add a return statement here. All right, so now we have both the create product and the getAllProducts endpoint implemented. So now let's start the application and check whether the application is going to start without any errors or not. All right, so you can see that we are able to start the application on the port 8080 without any problems. So now let's quickly go ahead and test whether our application, our REST API is working correctly or not. So I'm going to open Postman. So here I prepared a post request for the URL http localhost 8080/API/product. So this is going to be a post request. So for that, I'm going to provide a request body raw in the type of raw JSON. And here I'm going to create a request body of name as iPhone 13, description as iPhone 13, and price as maybe $1,200, right? So I'm going to send this request, and we can see that we got 201 created response back from our application. Now I'm going to copy this URL, and I'm going to create a new tab and paste in this URL. And now I'm going to send a get request to our API. And you can see that we received the product which we have created in the previous step. So our product service is working correctly, but we are doing this testing manually. The ideal situation would be to have some automated tests in the project. So let's go ahead and write some automated tests for our product service next. So to be able to write tests for our product service application, we can open the package source test, and under Java we have the test product service application test, which is auto-generated by the Spring Initializer for us. So we're going to write the test in this class, but before going ahead and writing the test, we are mainly interested to write integration test for this product service test, right? So we are not going to write a unit test, but we are going to create an integration test where we will spin up the application context, the whole application, and we will test whether the post API and the get API is working or not. So before going ahead and writing our tests, I'm going to first install a library called as test containers in our project. So if you're not aware of what test containers library, this is a Java library that supports us to write JUnit tests by providing some throwaway instances of common software we need, like databases, web browsers for Selenium, and RabbitMQ, message queues, and so on and so forth. Whatever external infrastructure we will be relying on, we can use that as external infrastructure software as Docker containers, and we can run integration tests in our project, right? So some examples are, you can test the data access layer integration tests using the Docker instances of MySQL, Postgres, or any other database. And you can also use the Docker containers for message queues, web servers, and also this can be used in the UI and acceptance tests using Selenium. So it provides many different Docker containers so that we can use this in our tests. So that's why we have the name test containers. So if you have a look at the modules which are supported, you can see that it has different databases, Elasticsearch container, gcloud module, Nginx module, Kafka containers, so on and so forth. We have a lot of modules which are available. As of now, in our unit, in our tests, in our integration tests, we want to have a container for MongoDB. So for that, I'm just going to click on the databases and select the MongoDB module. And here you can see the documentation, like the usage example, how we can use this MongoDB container in our tests. Right? So before we go ahead and use this MongoDB container, we have to first install test containers in our project, right? So for that, I'm going to click on Home, and I'm just going to scroll down until I find the section Maven dependencies. So if you want to install the test containers individually, you can just click on Maven and copy the whole dependency. So you can use this particular dependency. The other thing you can do is we can have, if we want to have multiple test container dependencies, right? If we want to have one test container dependency for MongoDB, one for Kafka, and one for, I don't know, any other module. It's a good thing to have a bill of materials, something called as a bill of materials, where you can just provide the version as in one place, and all the dependencies, all the other dependencies you use for the test containers will take the same version. I'm just going to copy this particular section, and I'm going to open my pom.xml, and I'm going to paste this particular code above the build section, right? Inside the dependency management section. And I'm just going to load the Maven changes. All right, so once this is done, now I can install the MongoDB container in our application, in our project. So for that, I'm just going to go back to the test containers website, and I'm going to click on modules, databases, and MongoDB module. And here I'm just going to scroll down until I find the adding this module to your project dependencies section. I'm going to click on Maven and click on copy. Go back to my pom.xml, and under the Spring Boot starter test dependency, I'm just going to paste in the MongoDB test container dependency. And again, I'm going to load the changes. So once this dependency is downloaded to your machine, I can remove the version, because as I'm already defining the version inside the dependencies management for the test containers bill of materials. I don't need to explicitly create the version one more time inside the dependencies section, right? So I'm just going to again reload the changes. So in this way, if I want to, no matter how many modules I use for the test containers, I can just define the version only in one place here inside the test containers bill of materials, right? So this is the advantage of using the bill of materials inside the dependency management section. And apart from this, as we are using JUnit 5 to write the tests, we also need to add the JUnit 5 supporting module for test containers. So for that, I'm going to open again the test containers website, documentation website, and I'm going to click on the section test framework integration and go to JUnit 5. And in here, all the way down in the adding test containers to JUnit 5 section, I'm going to click on Maven, and I'm going to copy this particular JUnit Jupyter dependency one more time. And going back to the pom.xml, I'm just going to paste this below the MongoDB dependency. And similarly, I'm just also going to remove the version tag from the JUnit Jupyter test container dependency, and thus I'm going to load this Maven changes. So now let's go ahead to the product service application tests class and start writing the integration test for our product service. So to get started, I'm going to add the So to get started, the first thing I'm going to do is to add the test containers annotation on top of the class, so that JUnit 5 understands that we are going to use test containers to run this particular test. And after that, I have to define the MongoDB container inside our tests, right? So for that, I can type in MongoDB container and create an object for the class MongoDB container. And to this MongoDB container, you can see that this MongoDB container class is deprecated because the Noah constructor, we cannot use the Noah constructor anymore. We have to manually specify the version of the MongoDB we want to use. So for the argument constructor, we have to provide the Docker image name for whatever software we want to use. So I'm going to provide the Docker image name as Mongo, and I'm going to provide the tag as 4.4.2, right? So this is the Mongo version I want to use for this test. So I'm going to add another annotation on top of this declaration called as container, so that JUnit 5 will understand that this is a MongoDB container. And I'm also going to add the static declaration because I want to statically access this particular MongoDB container and fetch the URL of the MongoDB database URI, right? So because as we are going to use this we need to set the URI of this MongoDB container in our test properties. So let's do that by first adding a method called as static void set properties. And this method is going to take a class, an object of type dynamic property registry. And inside this method, I'm going to type in registry, dynamic property registry dot add, and I'm going to type in spring dot data dot mongodb dot URI. And I'm going to here pass in the MongoDB container get replica set URL variable. So in this way, at time of starting the integration test, first of all, the test will start the MongoDB container by downloading the Mongo 4.4.2 image, and then after starting the container, it will get the replica set URL and add it to the Spring Data MongoDB URI property dynamically at the time of creating the test, right? Because if you remember, if you have a look at our source main resources folder, we have defined the Spring Data MongoDB URI manually in the application.properties file, right? But as here we are doing an integration test, we also have to provide the Spring Data MongoDB URI dynamically at the time of creating the test, because as we are not using the local MongoDB database, we are using a MongoDB Docker container. We have to provide the Spring Data MongoDB URI property dynamically. So to be able to provide this property dynamically, we also have to add another annotation on top of this set properties method called as dynamic property source, which will add this property to our Spring context dynamically at the time of running the test, right? So after adding all these configuration, we can go ahead and start writing our integration test. So the first test I'm going to create is for the product controller create product endpoint, right? I want to send a product object, a product request object, and I expect the response status to be created, right? So that's what I expect whenever I send a product request object. I expect the status to be created. So let's test this behavior. I'm going to open product service application test, and I'm going to change this context loads test to should create product. And to be able to make a request from our integration test, I'm going to make use of something called as a mock MVC, some object called as mock MVC, which will provide us a mocked servlet environment where we can call the our controllers, where we can call our controller endpoints, and we can receive a response as per the response which is defined inside the controllers, right? If you want a refresher on the testing concept of Spring Boot testing concepts, you can have a look at this Spring Boot testing tutorial crash course I have on my YouTube channel. It will provide a nice overview about what are all the aspects you need to know to be able to write tests using Spring Boot. right? So for now, I'm going to make use of the mock MVC object to make requests to the product controller. So for that, I'm just going to auto wire the mock MVC object into our test, right? And you can see that we are getting an error, could not auto wire, no beans of mock MVC type found, because we have to auto wire, we have to auto configure the mock MVC in our test. So for that, I'm just going to add an annotation called as auto configure mock MVC. Now you can see that the error is gone. That means our mock MVC is auto configured, and then now we can auto wire mock MVC in our test, right? So now I'm going to make use of mock MVC object, and I'm going to type in mock MVC.perform. This perform object, this perform method will take in a request builder and an object of type request builder. So for that, I'm going to type in mock MVC request builders dot post. As I want to do a post request, I'm choosing the post method, and in here I'm going to just type in /API/product, because this is the root URL of the product controller. I'm just going to copy this particular URL endpoint and provide it as the URL template. And after that, we also have to provide a request body of type JSON. So for that, I'm just going to type in .content type as media type application JSON, and I'm going to provide content as a string, right? I want to provide the content as a string. So for that, first we have to create the request body of type product request, because as we are taking a request body of type product request, first of all, I have to create an object of type product request. For that, I'm just going to create a method called as get product request. I'm going to create a method inside the test class, and in here I'm just going to return product request dot builder dot name is going to be iPhone 13, and description is going to be also iPhone 13, and the price is going to be big decimal dot value of $1,200 maybe, right? And I'm going to finally call the build method to be able to construct an object of type product request. And let me also just format this correctly, and also this method should return an object of type product request but not void. All right, so now we have the product request object ready. So I'm just going to also store this particular return object inside a local variable called product request. And now I want to send the product request object as the request body, but this content method will only take the object of type string. So now what I have to do is I have to convert this product request object into a string, right? So for that, I'm going to make use of something called as an object mapper, private object mapper from Jackson data bind package. So what this object mapper will do is it will convert a Pojo object to JSON and JSON to Pojo object. It will help us to convert this particular objects to JSON and vice versa. So I'm going to make use of object mapper, and I'm going to type in object mapper dot write value as string, and I'm just going to pass in the product request. And this write value as string is going to throw an exception. So I'm just going to add exception to the method signature. And finally, I'm going to store this written object into a local variable called as product request string. I'm going to provide this now into the content method. And finally, I'm just going to also define another exception from the perform method Alright, so now we have provided all the required input for calling the create product API. Now the next thing I want to do is I want to verify whether the request is going to be, the response status is going to be 201 created or not, right? So for that, I'm just going to type enter and type and expect, and I'm going to type in status. This is going to be a static method which is coming from mock MVC result matchers. I'm going to import the mock MVC result matchers dot status method, and after the status method I'm going to type in is created, right? So in this way, mock MVC will make a call to the API product create product endpoint by providing the product request string as a request object, and it will expect whether the status is created or not, right? So let's go ahead and run this particular test, whether it's working correctly or not. I'm just going to run the product application service test. Now what you're going to observe your very first time here is the test containers is going to, if it's not already available, it's going to pull the MongoDB image from the Docker container registry, right? So it will take some time as it needs to first pull the Docker image and then start running the test. And here you can see that the test has successfully created the MongoDB container and then started running the test against this MongoDB container, right? So if you go to the should create product, you can see that it has triggered the product service. Product with this particular ID is saved to the database. And let's do one verification whether the data is really saved or not. I'm just going to auto wire the product repository, right? And I'm going to verify product repository dot find all dot size is going to be 1, right? Because we have inserted one product, we expect that we should have one product inside the repository. So for that, I'm just going to type in assertions dot assert true, and I'm going to add this product repository find all size method call inside the assert true method, and just I'm going to verify whether the size is going to be 1, right? So after making sure that the create product endpoint is triggered successfully, we are also making another assertion that the product repository contains the product or not, right? And here you can see that the IntelliJ is suggesting us to, we can simplify this assertion. I'm just going to use assert equals here. So in this way, we can have the expected value and the actual value as the second parameter. So now let's make sure that we run the test again to verify whether everything is working fine. Yes, indeed. So the test is working fine. So in this way, we can have some automated tests in our microservice so that we are not always relying on the manual test. We can also have some automated tests in our microservice. So I'm going to give an exercise or a homework to implement also the test for the get product endpoint. I've created the test for the create product. Now it's your turn to implement the integration test for the get product. As this is going to be a microservice project, a microservice course, I'm not going to go in depth about the testing part. I've just provided you a hint on how to write the integration test for the microservices. Now you can go ahead and implement the required test for the other endpoints by yourself. I'm also not going to implement the test for the other services like order service and the inventory service. But if you are stuck when writing the test, you can find the test inside the GitHub repository. So I'm going to give an exercise or a homework to implement also the test for the get product endpoint. I've created the test for the create product. Now it's your turn to implement the integration test for the get product. As this is going to be a microservice project, a microservice course, I'm not going to go in depth about the testing part. I've just provided you a hint on how to write the integration test for the microservices. Now you can go ahead and implement the required test for the other endpoints by yourself. I'm also not going to implement the test for the other services like order service and the inventory service. But if you are stuck when writing the test, you can find the test inside the GitHub repository. So you can refer whenever you want and whenever you are stuck while writing the integration test. Alright, so now it's time to create our second microservice, that is the order service. For that, I've opened the website start.spring.io, and here I'm going to go ahead and create another microservice, our order service. So I'm going to type in inside the group ID, programming techie, and the artifact is going to be order service, and the name is also going to be order service. And I'm going to select Java 17 as the latest stable Java version. And coming to the dependencies, I'm going to add the dependency for Lombok and also for Spring Web. And as we are going to use MySQL database for the order service, I'm going to scroll down and add the dependency for Spring Data JPA. And lastly, I'm also going to add the dependency for MySQL JDBC driver. Once you have all these dependencies, you can just click on the generate button. As we are going to create more and more services, we have to maintain these services. We have to run these services parallelly by opening multiple IDE windows. So that will create a lot of load on your machine, right? So to get around that, what we can do is we can maintain all these services inside one project. So for that, I'm just going to create a new folder called as Microservices parent, something like this, and I'm going to move this product service and as well as the order service into the parent project. So in this way, I just need to open the microservices project microservices parent folder inside IntelliJ, and I will have both these projects inside one ID. Alright, so now I opened IntelliJ and I'm going to click on open and select the microservices parent folder which I've created before. Click on OK, and now you can see that we are able to access both the product service and as well as the order service inside one folder. So now let's open the order service and let's have a look at the pom.xml. We have the Spring Boot Starter Data JPA and Spring Boot Starter Web, and two dependencies for the dependency for the MySQL JDBC driver, Lombok, and the starter test dependency, right? So now first what I'm going to do is I'm going to create a package called as controller, and I'm also going to create some other packages so that we will have this structure called as controller, service, repository, and the DTO, right? Like how we did for the product service in this way, right? So let me create the package for repository, another package for DTO, and lastly we need another package for model, right? And for the order service, the model we are going to maintain in our database, in our MySQL database, is going to be to store the orders. So for that, I'm just going to create a new class inside model package called as order, and this class is going to be a JPA entity. So for that, I'm just going to add the entity annotation from JavaX persistence package, and I'm also going to name this table as t_orders, and I'm going to add a getter and setter annotation followed by noargs constructor and allogs constructor for the order class. And coming to the fields inside the order class, I'm going to add a primary key as ID with data type as long, and I'm going to add the ID annotation from JPA and also the generated value annotation with strategy as generation type dot auto. And I'm going to also create a string variable, and I'm also going to create a field called as order number, and followed by I'm going to create a list of order line items, right? So each order contains some items inside the order, so each order contains some order line items. So I'm going to create the order line items list, and we have to also create this order line items object class. We have to create this order line items class inside the model package. So I'm just going to create this class inside the model package. And this order line items is going to again have an entity annotation from JPA. This is going to also be a table. So I'm just going to add the table name as order t underscore order underscore line underscore items. So similarly to order class, I'm just going to add the getter, setter, allogs, and the noargs constructor from Lombok. And I'm going to also add the ID of type long, and I'm going to add the ID annotation from JPA, followed by the generated value annotation with strategy as generation type identity. And the next field I'm going to create is going to be order number of type string. And after that, we are going to have a list of order items inside the order. So for that, I'm just going to create a list of order line items. I'm going to call this as order line items list. I'm just going to import this list class from java.util package, and we have this order line items. And let me create this order line items class inside the model package. So this order line items class is again going to have the entity annotation from JPA, the table annotation, and I'm going to name this table as t underscore order underscore line underscore items. And I'm going to add the getter annotation and setter annotation from Lombok, followed by allogs constructor and the noargs constructor. So inside the order line items, I'm going to again have a primary key called ID, which is of type long. And I'm going to add the ID annotation from JPA, as this is a primary key. And I'm going to add the generated value annotation with a strategy as generation type dot identity, because then it will be, as this will be auto incremented, the primary key for each value, for each new record which we are saving to the database. And next in the order line items, we are going to maintain the SKU code. So I'm going to type in the field of type string called SKU code, followed by the field price, which is of type big decimal. And lastly, we will maintain the field called as quantity, which is of type integer. We have our basic model created, but we did not define any relationship between the order table and the order entity and the order line items entity, as this is going to be, as the order and the order line items is going to have one-to-many relationships. I'm just going to add one-to-many annotation, which cascade as cascade type all. So now we are done with the model part. So let's go ahead and create the controller and the endpoint, which will help us to create orders inside the order service. So for that, I'm just going to create a class called as order controller. I'm going to add the REST controller annotation on top of this class, and inside the request mapping, this is going to take the value /API/order. And inside the class, I'm going to create a post mapping, and I'm going to call the method as calls public string place order. And this method is going to just return a string called as order placed successfully by default. And this place order method is going to take a request body of type order request, and we don't have this order request class created yet, so I'm just going to create this class called as order request inside the DTO package. And here I'm going to add a data annotation so that we will have the getters and setters and all the default boilerplate methods for the class, and I'm also going to add the allocs constructor followed by the noaux constructor. And this order request is going to have a list of order line items DTO class. So this is going to be order line items DTO, and this order line items DTO is still not existing in our, we have to create this order line items DTO. So let's go ahead and create this order line items DTO class quickly inside the DTO package. And I'm going to just quickly copy and paste the whole annotations from the order request class and paste it on top of the order line items DTO class. And for the order line items DTO, I'm just going to open the order line items class and I'm going to copy everything there is inside the order line items class and paste it inside the order line items DTO, because we'll basically have the same fields inside the order line items DTO also. And coming back to the order request, I have to fix the compilation errors by first importing the list class from Java util package into the order request class. And now the next thing is to create a service so that it will create the orders inside the database. So for that, I'm just going to create a new class inside the service called as order service. And this order service is going to have a service annotation on top of the class. And in this class, I'm going to create a method called as place order. And this place order method is going to take the order request which is coming in from the controller, and from this order request I now have to create an object of type order. So for that, I'm just going to create new order object of type order, and I'm going to say order dot set order number as UUID dot random UUID. I'm going to provide some random UUID as the order number. And now I have to map the order line items which is coming in from the order request as the order line items DTO to the order line items inside the right. So for that, I'm just going to say order request dot get order line items dot stream, and I'm going to call the map function so that I can map the object of order line items DTO to order line items. So I'm going to type in here order line items DTO, and I'm going to create a method called as map to DTO and provide the order line items DTO as the method parameter. And I'm going to quickly create this method called as map to DTO inside the order service. And instead of returning an object from this method, I'm going to return an object of type order line items. And inside this method, I'm going to create an object of type order line items, and I'm going to just map all the fields which we have. Right, and finally I'm just going to return the order line items back to the place order class. And inside this map method, you can see that we can replace this lambda with a method reference. So I'm just going to replace it with a method reference, and I'm going to convert this to a list of order line items by using the .toList terminal operator. I'm going to introduce a new local variable called as order line items, and finally I'm going to set this order line items to the order by typing order.set order line items and providing order line items. And now we have constructed an object of type order. Now what we have to do is to save this order inside the database. So to save this order to the database, we need to create a repository. For that, I'm going to right click and go to new class, and I'm going to create a new interface called as order repository. And this order repository is going to extend JPA repository of type order, and the primary key is going to be of type long. Right. So now once we have the order repository, I can just inject this order repository into the order service. So I'm just going to type in private final order repository, And as this is going to be a constructor injection, I have to create a constructor parameter. For that, instead of creating the constructor manually, I can add the required args constructor annotation from Lombok. So then it will create a constructor automatically based on the parameters during the compile time. And I'm going to use this order repository inside the place order method. And I'm going to type order repository dot save, right? So in this way, we are receiving the order request from the client to the controller, and the controller is passing the order request to the order service. And inside the order service, we are mapping this order request to an order object and finally saving this order into the order repository. So now let's go back to the order controller class, and now we have to call this order service from the order controller, right? So for that, I'm just going to inject this order service by typing private final order service. And I'm going to also add the required args constructor, so that will have a constructor parameter for order service. And inside the place order method of the controller, I'm going to type in order service dot place order request, right? So whenever the user places the order, it will be saved to the database and it will return the text called as order placed successfully. And I forgot to add the response status, and the response status is going to be http status created. So let's test whether this is working or not. So I'm just going to open order service application, and I'm going to run this order service application, and you can see that we are getting an error because of course we did not define the data source attributes inside the application.properties. We did not define the database URL and all the related properties inside the application.properties file. So I'm going to do that now. So inside the application.properties file, I'm just going to type in spring data source dot driver class name. This is going to be com.mysql.jdbc.driver, right? And spring.datasource.url is going to be my JDBC URL. So just I'm going to type in JDBC MySQL localhost 3306. This is going to be my port on which MySQL server is running, and I'm going to call the schema as order service, right? And I'm going to type in spring.datasource.username as root, spring.datasource.password as MySQL, jpa.hibernate.ddl-auto is going to be update, and spring.datasource. And lastly, I'm also going to add the server.port as 8081. As on 8080, we are running the product service. We want to run the order service on port 8081. Right? So let's go ahead and start the application now. And you can see that the application is started successfully, but we see a warning that the class MySQL JDBC driver is deprecated and the new class is com MySQL CJ JDBC driver. So I'm going to use this driver instead of the other one. So I'm just going to paste this inside the application properties, and I'm just going to restart the application one more time. And now you can see that the application is started on port 8081. So now it's time to test whether the endpoint is working correctly or not. So I'm just going to open the Postman client. I'm going to open the Postman client, and then now I'm going to type http localhost 8081/API/order. And I'm going to send a request body of type JSON, and in this request body I'm going to send the fields for the order request. So it's going to be an array of order line items DTO, right? So I'm just going to create an order line items DTO array, and inside that array I'm going to first send the SKU code, price and quantity, right? And instead of order line items DTO, it should be order line items DTO list. The name of the key value of the JSON is going to be order line items list. And inside the object, I'm going to create a SKU code, price, and quantity, right? So I'm just going to create an object for SKU code and an object for price, and this is going to be 1200, and quantity is going to be 1, right? And for the SKU code, I'm just going to type in iPhone _ 13, and I'm going to just click on 13. And I made a mistake here. It should be localhost 8081, but not 8082. And also I have to send a post request to the order service. So now with this request body, if I click on send, I should receive a success response, order placed successfully, with status as 201 created. That's perfect. Now the next thing we have to do is to create the inventory service, which will check whether the products are in stock or not, right? So let's go ahead and do that. All right, so now I'm in the start.spring.io website, and it's similar to the other two services. I'm just going to leave the defaults for the Spring Boot options and also the packaging, and the Java version I'm going to add it as 17. The only change I'm going to do is to change the artifact name to inventory service, and I'm going to add the dependencies similarly to order service. I'm going to add the dependency for Lombok, dependency for Spring Web, dependency for Spring Data JPA. I'm just going to scroll down until I find Spring Data JPA, and the dependency for MySQL. You know what? Why I'm scrolling down, I can just search for MySQL driver here. So I can just select MySQL driver, and once everything is done, I'm going to click on generate. All right. So open the inventory service project inside your favorite IDE, and after that, I'm just going to open source main resources, and the first thing I'm going to do is to configure the MySQL database properties inside the application.properties file. So for that, I'm just going to leverage on the changes we did for the order service. So I'm just going to open the order service and just copy all the properties which you have defined inside the application.properties, and I'm going to paste it inside the application.properties of the inventory service. So one question you may have is, why did I not add the inventory service already inside the microservices, microservices parent, right? Because at this moment I'm facing some issue to add the inventory service to the microservices parent, but we are going to add them to one project by creating Maven multi-modules further down the project. So you can just continue by opening the inventory service in a new IDE, and we'll do the refactoring later, right? And the next thing I'm going to do is to change the server port to 8082, because 8080 is taken by the product service, 8081 by the order service, and 8082 will be assigned to the inventory service. So now the next thing I'm going to do is to create a package inside the root package called as model, and inside this package I'm going to create a new class called as inventory, and this inventory class will act as the model where the actual inventory which we are storing in the database. So for this reason, we are going to add the entity annotation from JPA, and we're going to add the table annotation also with the name as t_inventory, and we're going to add the getter annotation, the setter annotation, all args constructor, no args constructor annotation, and inside the inventory class I'm going to add a primary key called ID with ID annotation from JPA, and generated value annotation with strategy as generated value type.identity. And after that, I'm going to add the field called as SKU code, which represent the product, and lastly, I'm going to add another field called quantity, which will provide the number of items which are in stock for this particular SKU code. Right. So the next thing I'm going to do is to create the repository for this corresponding JPA entity. So for that, I'm just going to create the repository package and create an interface called as inventory repository. And this inventory repository is going to extend JPA repository, because as we are using Spring Data JPA and Spring Data JPA to store for the persistence, and for the JPA repository we have to provide the inventory as the first generic argument, as the JPA repository is going to take two generic arguments. The first one is going to be the type of object which you're going to store, and the second one is the type of the primary key. And here the type of the primary key is going to be long, so I'm going to add the type as long. So the next thing is to create the controller where we can create our endpoints, right? So I'm just going to create the controller package and create the inventory controller class, and similar to all the controllers we have created, I'm going to add the REST controller annotation and the request mapping annotation with value as /API/inventory. And in here, in this inventory controller class, I'm going to have only one method, and this method is going to be a get mapping. So we're going to make a get call to get the inventory status, and this response status is going to be http status dot OK, and the method name is going to be public boolean is in stock, right? So what this particular endpoint is going to do is it's going to take in a SKU code, and it's going to verify whether the SKU code, or means the product, is in stock or not, right? So for that we have to take in the SKU code as a request parameter or maybe a path variable, right? So for that, first what I have to do is I have to add the path variable to the get mapping annotation. So I'm just going to type in slash and type SKU code, and I'm also going to add the path variable annotation here. It's going to be string SKU code, and as this is not going to be as part of this naming conventions, I'm just going to add the path variable as SKU code. So now inside the is in stock method, I have to query the database to check the inventory. So for that, we are not going to access the inventory repository directly. We are going to create a service class. So for that, I'm going to create a package called as service, and inside the service, I'm just going to create a class called as inventory service. And this inventory service is going to have an annotation called as service, because this is representing a Spring Boot service, right? So inside this inventory service class, I'm going to create a method called as public boolean is in stock, and this is going to take in the string SKU code as an input parameter. And inside this is in SKU code is in stock method, I'm going to query the inventory repository, right? So for that, I need to inject the inventory repository into the inventory service, where private, I'm going to type in private final inventory repository, and I'm going to add the constructor parameter by typing the required args constructor annotation from Lombok. And inside the is in stock method, I'm going to type in inventory repository dot find by, and I don't have any method with the find by extension, so I'm just going to type in find by capital S SKU and capital C code. So this will going to be an extension method from Spring Data JPA. So I'm going to create this method in the inventory repository. So Spring Data JPA is going to automatically implement the logic for this find by SKU method. So at the runtime, Spring Data JPA will generate the query to retrieve the inventory by the SKU code, right? So this find by SKU code method should not return a type of void, but it should return an optional of type inventory, right? So I'm just going to import the optional class from Java util package, and let's go back to the inventory service. And here I'm just going to return this optional dot is present value, right? As the find by SKU code method is returning an optional, I can just type in dot is present to check whether the object is present inside the optional or not, and I can just return the value from the is in stock method directly. And lastly, I'm going to add the transactional annotation on top of this method, and this transactional is going to be read only transactional annotation from Spring Framework, and I'm going to add the read only attribute as true. Well, I think we have forgot to add the transaction annotation on the order service, so let me check once. So I'm going to open source main Java service order service, and yeah, we didn't add the transactional annotation, right? So I'm just going to add the transactional annotation on top of the class by typing transactional from Spring Framework transaction.annotation package, right? So in this way, Spring Framework will automatically create and commit the transactions. Once this is done, I'm going to go open the inventory controller class, and I'm going to now call the inventory service.isInStock method from the inventory controller. So for that, I'm just going to type in inside the inventory controller private final inventory service, and I'm going to add the required args constructor from Lombok, and here I'm going to type in return inventory service dot is in stock, and I'm going to pass in the SKU code. So in this way, we have created an endpoint which takes in a SKU code as the path variable and queries the database based on the SKU code, and will return the response whether the inventory is whether the product is in stock. And one last thing we have to do is we have to create the data inside the database, right? So if we try to run the application and if we try to query this particular endpoint, of course it will return false by default because there is no data inside the database, right? So for that, what I can do is I can create a bean inside the inventory service application class. So what this bean will do is it will try to load the data at the time of application startup. So for that, I'm just going to type in bean definition. So I'm just going to add the bean annotation followed by the method public command line runner load data. I'm going to name this method as load data, and this bean is going to take the inventory repository as the method parameter. So this will be injected through the method injection, and inside this load data method we are going to create a supplier, and inside this supplier I'm going to first create an object for the inventory class. So I'm going to first set the inventory SKU code as iPhone_13 and the quantity as 100. So I'm going to now create another inventory object called as inventory1. So here the SKU code is going to be iPhone 13 red, and for this inventory I'm going to set the quantity as 0, right? So after defining these two objects, I'm going to save these two objects into the database. So for that, I'm going to type in inventory repository dot save inventory, and for the inventory1 object, I'm also going to do the same thing, inventory repository dot save inventory1. So at the time of application startup, this bean will be created, and as part of this bean, we are going to create both these objects and save to the database. So before we test whether this is working correctly or not, I'm just going to open MySQL Workbench, and I'm going to first create a schema called as inventory service. I'm going to click on apply and also apply. This will create the schema inventory service. And now let's go to the inventory service project inside IntelliJ and start our inventory service application. So you can open inventory service application and just click on this debug option, and at the time of startup it should execute this particular piece of code where it will save the inventories to the table, to the repository, inventory objects to the repository. So let's check whether this is executed correctly or not. Yes, it does. So we have two objects, iPhone 13 and iPhone 13 red, inside the database. Alright, so before I've said that instead of maintaining these two projects, inventory service and microservices parent, we're going to club everything into one project. We are going to create one parent project, and we are going to maintain all our services into that parent project, right? So let's try to do that now. So what I'm going to do now is I'm going to create a new Maven project, completely new Maven project inside IntelliJ. So for that, I'm going to go to File, New Project, and I'm going to select the option Maven, and make sure to select the version you like. I'm going to select JDK 17 here, and I'm going to click on Next. And here I'm going to provide a name called as Microservices New. So this is the project name I'm going to give. It's like a new parent. And in the artifact coordinates, I'm going to name the group ID as com.programmingtechie. And the artifact ID, I'm going to leave it as Microservices New. And I'm going to click on Finish. And I will going to click on New Window. It will ask whether to open the project in this window or in a new window. I will click on New Window. And now you can see that it created an empty Maven project, which contains just an empty source main Java folders, resources, and the test resource folder and the test folder. And it's just a complete empty Maven project, right? So what I'm going to do now is I'm going to create three modules, one for the product service, one for the order service, and the other one for the inventory service. So inside this Maven project, I'm going to create a Maven module. So for that, I'm going to right click and go to New Maven Module, and again select the SDK as JDK 17, click on Next, and I'm going to name this module as Product Service. And I'm going to check whether the artifact coordinates are similar to the group ID we have provided for the root project. And the artifact ID is going to be product service. Click on Finish, and this product service module is now created again with a pom.xml file. You can see that the artifact ID is product service. And if I open the pom.xml for microservices new root project, it's also added inside the module section, the product service. So similarly, I'm going to create a module also for the order service and the inventory service. Alright, so now we have all these three modules inside our root project. So as we have these modules, we don't need the source folder anymore. So I'm just going to delete this source folder. And now what I'm going to do is, now I'm going to migrate all these three projects we have before inside this microservice parent and in the inventory service. I'm going to migrate this into the microservices new project. First thing I'm going to do is to open the pom.xml of the product service. So inside the microservices parent, I'm going to open the pom.xml of the product service, and I'm going to copy everything under the dependencies section. So I'm going to copy everything which is inside the dependencies section. So all the way down here, I'm going to copy the dependencies tag, and I'm going to paste it inside the pom.xml of the product service. So just beside the properties, just below the properties, I'm going to paste in the dependencies section, right? So after adding this dependencies section, so now what I'm going to do is I'm going to do the similar thing also for the order service. So go back to the microservices parent, open the pom.xml of the order service, and again copy the dependencies inside the order service, and go back to the order service inside the microservices new, and paste them just below the properties tag. Alright, so now we have the dependencies for the order service. Let's do the same thing also for the inventory service. I'm going to open the inventory service, pom.xml, and copy everything inside the dependencies, right? So copy it and open the inventory service inside the microservices new folder, and again, similar to the other two projects, I'm going to paste in the dependencies just below the properties tag. So now we have the dependencies in all three projects. Now what we need is the inside the product service of the microservices parent. I'm going back, right? So I'm switching a lot between these two projects. I hope you are understanding. So I'm inside the product service of the microservices parent, and in here we have the dependency management tag, right? So this is where we are defining the version of the dependencies for the test containers. So I'm going to copy this dependency management tag, and I'm going to add it inside the root folder. I'm not going to add it inside the product service, but I'm going to add it inside the root of microservices new project. So you may get the doubt why I'm adding it in the root, because if I add it in the root, and if you want to have the test container dependencies inside the order service and as well as the inventory service, you don't need to repeat yourself, right? Inside the product service, before we are adding the dependency management tag, and instead of repeating them on each module, I can just define this inside the parent module under the dependency management tag, and this dependency will be like propagated to all the child's services like order, inventory, and the product service. So that's the main reason we are adding it in the parent. And another important thing we have to do is to open the microservices parent. Like you can open any of the pom.xml, and you can see that the parent is defined as Spring Boot starter parent for each of the services like product service, order service, and the inventory service in the old setup, right? So what I'm going to do is I'm going to copy the parent, and if I open for example product service, you can see, if I scroll up, you can see that the parent is microservices new project, right? But to be able to download all these dependencies to our project, we have to define the parent as Spring Boot starter parent. So for that, what I can do is I can go to microservices new project, and I can define the Spring Boot starter parent as the parent of the microservices new project, right? So in this way, if microservices new project is the parent for order service and the inventory service, so this Spring Boot starter parent will be the grandparent of order service, inventory service, and the product service. So in this way, all the version will be downloaded without any problems to our project. So if I click on the load Maven changes icon, all the dependencies will be downloaded without any problems, right? And one last thing I have to do is now to add the Spring Boot Maven plugin, right? If I open one of the old setup, so if I go to product service, we have this plugin information here, right? Like the Spring Boot Maven plugin, and also in the order service we have the Spring Boot Maven plugin, right? So I'm just going to copy this whole build tag where we have the compiler plugin and the Maven plugin, and similar to dependency management, I'm going to add it inside the root project, inside the microservices new pom.xml. So in this way, the Spring Boot Maven plugin and the compiler plugin will also be added to all the child projects, right? So again, I'm going to load the Maven changes to make sure that there are no problems in the setup. So to be able to test whether everything is working correctly or not, we have to also copy the source code, right? So now if you check the services, we don't have any code inside. We have already developed the code for this one. So what I'm going to do is I'm going to first delete this source folder inside the product service. I'm going to do the same thing also for the order service and the inventory service, right? So what I'm going to do now is I'm going to copy the source code from the old projects. So I'm going back to the microservices parent project, and I'm going to copy the source folder from the product service. Just right click, copy, and just paste it under the product service. Right click, paste, new name will be source, click on OK, and everything will be copied without any problems. Similarly, I'm going to do the same thing for the order service. So go back to the old project, microservices parent, copy the source folder, paste it inside the order service. It's fine. And now open the inventory service, copy the source folder, and paste it inside the inventory service, click on OK, and everything we should work without any problems. Now, just to verify that everything is working fine, what I can do is I can run a command called as Maven clean verify. So I'm going to open the Maven tab to the right side of the IntelliJ IDEA, and I'm going to click on this M icon to execute a Maven goal. And here I'm going to type Maven clean verify, right? So what it will do is it will just run the compile. So it will try to build the project without trying to install everything. And finally, you can see that the build is success, and it took total of 29 seconds on my machine to execute this. And lastly, let's check whether the applications are also working correctly or not, like are also able to start up correctly or not. So I'm going to open source main Java product service application, and I'm going to run the product service application. So you can see that the application is started without any problems. The product service application and the order service application. Let's start this one more time, and it started successfully on port 8081. Lastly, the inventory service. Let's start this application, and also you can see that it started successfully on port 8082, right? If you are facing some problems, if you're not able to replicate the same result as I am, you can download this whole project from GitHub. I will upload this as a starter project for this particular series in GitHub. You can download this project and you can start working from that point, right? So again, you can check the initial setup branch inside the Spring Boot Microservices new repository, and there you will find the complete setup, the initial setup, which we have just did before, right? So just download this project if you are facing any problems, and then you can start coding along with me from now on. Alright, so before we go on, there is a small bug inside the inventory service, inside the inventory service application class. So we are running this load data method multiple times so we are running this load data method whenever we are starting up the application, right? So that means whenever we are starting up the application, we are inserting this two inventory objects into the database. So that means for sure we have some duplicates inside our database. Let's go open our MySQL workbench, and I'm going to run the select query, and you can see that this particular iPhone 13 and iPhone 13 red SKU code inventory objects are duplicated. So to prevent this, for now, what I can do is I can just select all these duplicated records, and I can just try to delete them manually. Delete and click on apply, and this will delete all the records from our table, right? And to make sure that it won't occur one more time, what I can do is I can go to resources, application.properties, and as this is not a production application, I'm just going to add it as create drop, the DDL auto as create drop. If you are using it in a production setup, please don't use create drop. You have to use DDL auto as none. and you have to use a database migration library like Liquibase or Flyway to do this kind of migrations. So please don't use create drop. This is just used as a demo purpose, and please don't take this as a recommendation to add this inside your production code, right? So having said that, let's restart the inventory service application. And now if you open the inventory service, click on select, you can see that we still have the 2 records. We are not duplicating it because it's creating, and it's first dropping and then creating the schema again.